In this module, we'll see what happens when a certificate has to be killed early. You'll learn why we revoke certificates, how ADCS publishes CRLs, and how Windows clients use tools like Certs to decide whether to keep trusting or block a certificate. You've gone from PKI fundamentals to building an ADCS lab to issuing certificates and wiring them into real services like IIS, RDP, users, and computers. Now we'll close the loop with revocation, so you can decide, enforce, and publish when a certificate must stop being trusted. Certificates don't suddenly stop mattering when they expire. Most of the risk is everything that happens before that date. If a private key is stolen, a server is decommissioned, or a person leaves a role, the certificate is still time valid but no longer safe. Revocation lets the CA signal do not trust this anymore, and clients that check revocation data avoid both silent security gaps and surprise application failures. Think of revocation as an emergency brake in the certificate lifecycle. Normally, a certificate is requested, issued, used, and eventually renewed or allowed to expire. Revocation is different. The CA actively decides a still valid certificate must no longer be trusted. Its serial number is added to the CA's revocation data and published in a CRL, and clients need to download and check that CRL before trusting any certificate from that CA. Revocation reasons aren't just paperwork. They tell the risk story behind every revoked certificate. Key compromise or CA compromise signal, high urgency, and usually drive incident response. Affiliation changed, superseded, and cessation of operation are more administrative, documenting lifecycle changes. Certificate hold is different. It's a reversible pause, useful when you're unsure if a key is actually compromised. Choosing the most accurate reason pays off later in audits, reporting, and forensics. Key compromise is a localized problem. An attacker gets the private key for a single certificate, so they can impersonate that one user or server. You respond by revoking that certificate and reissuing new keys. CA compromise is an infrastructure problem. The authority that signs many certificates is no longer trusted. In that case, every certificate from that CA may be suspect, and large-scale emergency replacement is required. Not every revoked certificate means something went wrong. Use affiliation changed when a person moves roles or departments. Their old certificate no longer matches their new responsibilities, so it should be revoked and reissued. Use superseded when you replace a certificate, maybe for a stronger key or new endpoint. Use cessation of operation when a system is retired. Handling these cleanly keeps your PKI tidy and limits unnecessary trust. Certificate hold is like pressing pause on trust. You suspect a problem, but you're not sure yet, so you temporarily treat the certificate as revoked. Clients should see that hold status in revocation data and refuse the certificate just like a full revocation. If the investigation clears the risk, you can unrevoke it and restore trust. Because this is reversible, you need clear policies so holds don't turn into a shortcut for sloppy decisions. Revoking a certificate is a two-part job: changing CA state and updating what clients see. First, the CA marks the certificate as revoked with a specific reason and effective date. That can be done in the console or with Certs in scripts. Then you publish a fresh CRL and make sure it's reachable. Only after clients download that updated CRL will they actually treat the certificate as revoked. When a client validates a certificate, it doesn't just check the signature and expiry date. It also follows the CDP URL in the certificate to download the CA's certificate revocation list. That CRL is signed by the CA and contains serial numbers, revocation dates, and sometimes reasons. The client looks up the certificate's serial number. If it's present, the certificate is treated as revoked and the connection must not be trusted. Once a certificate is revoked, nothing changes for clients until a new CRL is issued and downloaded. The This Update and Next Update fields define how long that CRL is considered fresh. If you choose long validity, clients make fewer downloads, but a newly revoked certificate may remain trusted for hours or days. Short validity lets clients learn about revocations quickly, but forces your CRL service to publish and stay available much more frequently. Base CRLs are the authoritative snapshot of all revoked certificates for a CA. They're larger and updated less often, but every client must trust them as the baseline. Delta CRLs only carry the changes since that snapshot, so they're smaller and can be published much more frequently. The trade-off is client caching. If a client keeps an old base CRL too long, it might miss revocations until it refreshes both base and delta. Certutil is your Swiss Army knife for testing revocation from a client's point of view. Run Certutil URL against the certificate to confirm the client can actually reach the CDP and AIA locations. Then use Certutil. Verify to check the full chain and see whether Windows treats the certificate as valid or revoked. Between tests, clear the cache with Certutil URL cache or delete, so you're always seeing fresh results. Every major service you run is making its own decision about revocation. Browsers, RDP, IIS, VPN, Wi-Fi, and authentication tools all check CRLs or OCSP a little differently. Some fail hard, some quietly allow traffic, others only warn. So you can't rely on one test. Confirm the CRL is published and reachable, clear caches, validate with Certutil, then repeat the same scenario in each application and record exactly how it behaves. You've learned how to revoke certificates for the right reasons and how those reasons document why trust was removed. You've seen how CRL publication schedules control detection time and how to verify client checks, caching, and app behavior. Next, we'll protect the CA itself with backup and recovery.